Japan Agency for Marine Earth Science and Technology. And yeah, so we will have 4 talks and 2 local talks and 2 remote talks in series. And then yeah, each perhaps maybe the 10 minutes per person. And then we will have the Q&A session in the end. So yeah, let's start. And I'm going to give an overview introduction of this session first. And here you see the typical, very typical DP, so-called well-known DP-SIR framework, that is a causal framework, and also the knowledge action linkage to be applied to any given environmental problem, like, sorry. The driver here can be the globalization, and the pressure can be the emission increases, and state can be the change in the atmosphere and the ocean. Impact is to be in the climate and health or any perspective, and the response will work as a policy makings and yeah, working on the drivers to mitigate the issues. So then, yeah, that is a typical diagram, but today we have the 3 categories of the environmental issues like climate change, air pollution, and ocean pollution. And then we only have the 4 speakers about this large-scale talk. So then, yeah, I'm gonna talk about the air pollution from the perspective of the state, and Mariko Harada from JAXA will talk about the climate change with greenhouse gases, and the Ecosys Wanto will talk about the ocean pollution from the ocean color perspective, and then the Eric Zussman will talk response on the governance, policy governance issue. So then, yeah, understandably, there are large gaps between talks, and please let us, yeah, apologize about this. But yeah, but we try our best to seek the possible linkage between our talks and also the synergy and toward the multiple goals or the targets as shown in the right-hand side, like IPCC, UNFCCC, and the LGO, and the SDGs. So yeah, let me start about the air pollution part. And yeah, my background is about the atmospheric chemistry and the optical instrument development and measurements. So then, yeah, and also I served as an IPCC AR6 Working Group 1, Chapter 6, that would be the short-lived climate forces, the review editor. So yeah, based on this, I'm gonna talk about the pollution status, the research status in Japan. And as shown in the right lower corner, yeah, I will talk about main issues like ozone, PM 2.5, and recent satellite development, and new research integration toward the GHG and AQ joint studies, and the black carbon mitigation. So talking about ozone, we have struggled a lot for the past 50 years, and yeah, finally, that after the reduction of the non-metal hydrocarbon and NOx, as shown in the lower left corners, that they decreased a lot, but ozone was increasing, was the previous issue. But recently, as shown in the left top corner, at various regions in Japan, somehow the high ozone episodes finally seem controlled, but still at the risky levels, as shown in the purple line, the horizontal line. The national standard in Japan is pretty tight. It's 1 hour 60 ppb. So then this is still difficult to attain. And in the right-hand side, the model simulation has shown that in the near future, in 2030, the VOC limited regime region should be diminishing. And yeah, this is particularly because of the reduction of NOx emission, and also that NOx limited regime will be more prevalent. So then the region-specific or sector-specific policy making is pretty much needed in the future. Yeah, but the basement of this assessment is the very good understanding of the science of the ozone production. And so here in this slide, I show that the understanding of the fundamental NOx chemistry processes is still incomplete. And in the left-hand side panel, we show some schematic diagram as already introduced, the catalytic formation of ozone via the radicals as shown, but yeah, still unknown or emerging species present like Hono as shown in the right-hand side. And this is still very difficult to model, and its impact on the OH and also the ozone formation is quite missing. And as shown in the right top panel, there was a Emerge Asia aircraft-based campaign done by the University of Bremen in 2018 and has measured HONO concentration up to 100 ppt over the very clean marine region, surprisingly. And this is quite difficult to model. And yeah, we are still struggling how to reproduce these high levels. And one idea would be the heterogeneous reaction of NO2 forming the HONO, but yeah, it's still on the quite sensitivity study stage. And in the lower right panel, they're showing the ozone diurnal variation in Tokyo. And there are several three model simulations trying to reproduce this, but the only one successfully reproducing is a NACIUM. That is actually the Chinese model. But yeah, only if they form the heterogeneous loss of HNO3 forming NO and NO2, the renoxification is assumed. The ozone concentration is only well reproduced. So such fundamental studies are still necessary for tackling the ozone issues with the right knowledge. So talking about the PM 2.5, it was in 2013 that the PM 2.5 of China is pretty much broadcasted, and even the annual average, it was 72 the microgram cubic meter. And in Korea is in between, and Japan is in the lower level in the green. And yeah, successfully over Japan, the annual average, the country average concentration has decreased. And yeah, recently the satisfaction of the national air quality standards, that is 15 microgram per cubic meter in our country, is quite well satisfied. But it's still higher than the new WHO air quality guideline that is set to 5 microgram per cubic meter. And during this phase, for the reduction, the scientific knowledge-based decision was quite nicely made. And actually, as shown in the right-hand side, the PM 2.5 contributions from the attribution of the PM 2.5 to each country's, the domestic contribution likely 20 to 50%, depending on the season. Korean Peninsula could have some lower contribution to Japan, and also the China has a pretty large contribution. So these information were delivered first to the policymakers, and then the strategy was made. So that was a good history of Japan right now. And also, yeah, the new question would be what is the truly health-affecting chemical species out of the mixture of the PM 2.5 is quite important to identify scientifically. And the new movement is on the new satellite NO2 monitoring. So in the top left panel, we show the quite dense monitoring, surface monitoring of NO2 over Japan, like Tokyo area, but it is still the sporadic, I would say, and it is not smoothly connected. The spatial gap is present. So this is to be highly filled at high resolution is our motivation. As shown in the right top panel, the Korean geostationary satellite works quite well for the NO2 monitoring recently, and even the diurnal variations with the identification of the morning peak of the traffic or something like that could be detected. And in the lower right-hand panel, even the 1 kilometer mesh monitoring from the satellite is to be made because of the advancement of the optical technology. And yeah, as you see, even single power plant sources could be identified because of this. And yeah, we aim to do this for the air pollution perspective as well as for the CO2 big source to identify. And next, the Mariko Harada-san will talk more about the GOSAT-1 and GOSAT-2. That is a GHG monitoring satellite that with the Japan initiative. But yeah, here I'd like to mention that the GOSAT-GW, that is the third generation of the GOSAT-3s, will take into account the NO2 monitoring as well, as I've mentioned. And air quality joint studies are also important shown in the left-hand panel. Even in the various future scenarios, altogether as a SLCF, short-lived climate forces, that the aerosols, methane, ozone, and HFCs will contribute some amount of the increase of temperature in the range of 0.1 to 0.7 degrees Celsius toward the end of this century. So then this is pressurizing. This will reduce the allowable CO2 emission in the future, actually. So it is told that the global surface temperature increase is mostly linearly dependent on the cumulative CO2 emissions. That is a key feature of the IPCC report. And yeah, we are already we are on the 1.1 degrees Celsius already. And if we target the 1.5 degrees, there's some gap between that. That may tell that the future allowed the CO2 emissions, that is sometimes called the remaining carbon budget, but it is pressurized by the trajectory of the SFCF. So the co-control of the GHG and the quality is also important. So yeah, almost the time is up. So then, yeah, I'd like to talk about just briefly about the black carbon has reduced much from the Chinese emissions. And then sometimes even the bottom-up emission inventory as shown in the left lower corner, the CDS was totally wrong, actually too high, and the increasing trend was totally wrong. So it was a key input parameter for the CMIP6 climate simulations in the IPCC-L6. So the fundamental gap is to be filled from the in situ observation in these cases. So yeah, we are already in the global network and are trying best to organize the monitoring from the ground-based and including the Pandora global network, Pandonia global network using the Pandora instrument promoted by NASA and ESA, and our own Max-DOS network is working for more than 10 years. ENET and TOR2 initiative is also made from Japan. So yeah, I will not talk about the summary in detail, but yeah, lastly, the hyperspectral observation has a good capability of monitoring the GHGs, air pollutants, and ocean color measurements are to be introduced in the series of talk. So then that would be the one good part to move forward in this research field. So thank you very much. And yeah, I'd like to invite Mariko Harada-san from JAXA talking about the GHG studies.
Oops. Yeah, thank you for the introduction. Hi, my name is Mariko Harada from Japan Aerospace Exploration Agency. And I am not a scientist, engineer. I'm associate senior administrator. Well, my task is about to promote and integrate all the international coordination among all the stakeholders and focusing on Earth observation satellites. So today I like to present a satellite technology for GHG monitoring and policy relevance. Oops. Well, Japan has been operating Earth observation satellites for more than 30 years. Well, currently we are operating 6 satellites shown here. From the left-hand side, ALOS-2, this is the radar satellites, well, mainly monitoring disaster and forest and all the land cover. And the second one, the GPM core, which is the joint mission with NASA, is a global monitoring for precipitation. So since 2014, it's been operating and observing all the precipitation around the world. On the third, this is GEMM W. It's launched in 2012. This is observing water cycle on a global scale. On the bottom, this is launched in 2017. This is GEMM C, and which is dedicated to monitor all the climate change observables like cloud and aerosols and vegetation. So from to atmosphere to land to the ocean. So all the layers. And today I'd like to more focus on this GOSAT and GOSAT-2. The first one launched in 2009, and the GOSAT-2, the following successor, launched in 2018. Those missions observing greenhouse gases, mainly CO2 and CH4, methane. And for the successor, GOSAT-2, now added CO as well. And all those missions are operating for all scientific purposes, but also to contribute to the global agendas like UN Sendai Framework, the SDGs, and also the important one, the Paris Agreement. So then why we observe GHG from space? Well, the one advantage of satellite observation, as you may all know, that it has a wide coverage and can uniformly observe entire globe, and also it's borderless. So with this advantages, we are aiming to contribute to the global stocktake, which is under the Paris, which are implemented under the Paris Agreement. With specifically will improve the transparency and support the evaluation and improvement of mitigation policies. Well, as the previous speakers mentioned many times, the national GHG inventories are based on activity data by national statistics. And according to the Paris Rulebook, the parties submit their GHG inventories, emission reduction goals in form of national determined contributions, so-called NDC, and submit biannual transparency reports, which includes information on the progress of the NDCs. And for reporting the national emissions, the parties are now requested to use the 2006 IPCC inventory guidelines and the latest refinements adopted in 2019. And this latest requirements adopted in 2019 now includes many description on the usability and roles of satellite data as a comparison tool of inventories. Particularly a section of satellite observations are newly created. So a 5-year global stocktake cycle has been defined to monitor changes in global emissions. The first global stocktake is scheduled to begin next year, 2023, and technical and other dialogues are currently in progress. At the end of each global stock cycle, national inventory reports will be compiled and compared to observe changes in the amount of greenhouse gases in the atmosphere and other parts of the Earth system. So the GOSAT and GOSAT-2 is quite unique in our Japanese Earth observation program. Which is because, as shown here, the three main players are jointly teamed up to operate this mission. The Ministry of the Environment holds all the GOSAT mission budget and policy. And under the Ministry of the Environment, JAXA and National Institute for Environmental Studies, Japan, collaborate each other to develop all the missions. So for JAXA, we developed the sensors and also the satellites and launch all the continuous satellite operations and data acquisition and so on. So this is kind of unique for us to the Ministry of the Environment holds this GOSAT missions, and this is intent to use these GOSAT data for environmental policies. This is the point I'd like to mention. So as I mentioned, the GOSAT launched 2009, so it is observing the whole GHGs for more than 10 years. So as shown on the left, the CO2 has been increasing as shown here. On the on the right hand, it is the figure of CH4 methane trends. Those are all you're familiar. All of those data shown that it is increasing. So the GOSAT and GOSAT-2 has the world's longest record of these data. So with this efforts and our results, we JAXA started a new initiative to apply satellite technology to passenger aircraft. I don't know who all of you know the ANA, one of the flagship Japanese carrier. With a joint with JAXA, we launched the greenhouse gas observation of biospheric and local emissions from upper sky week, so-called Go Blue. With this project, we use the ANA passenger aircraft and carry those sensors on the passenger cabin to detect the GHGs. So the satellites are usually operated more than 600 kilometers above, but aircrafts fly almost 10 kilometers upper in the sky. So high resolution data can be acquired. So the goal is to estimate the global greenhouse gas emissions by source sectors, such as transportation and industries. So this is the actual photograph of the observation. With the aircraft, we carry on these two luggage size instruments and put it on the cabin seat. And with that, we put the cameras outside the cabin so we can observe through these windows. With that, NO2 and CO2 solar induces chlorophyll to fluorescence, SIF, can be observed. So this is the actual result of Go Blue observation. It seems like, okay. Which flew from Haneda to Fukuoka as main route over the major city in Japan. So focusing on Osaka, you can see the concentration of NO2 over the Osaka. So it has relevance with the major roads in the Osaka. So it has a high concentration, density concentration around there. And now we are cooperating with local government, which is Fukuoka City, and they agreed to provide the in situ data, which actual measure data on the traffic volume. So this will make it possible to estimate emissions by sources, and it's expected to dramatically advance the development of methods for detecting greenhouse gases emissions in city areas, focusing on city areas. So, well, due to time constraints, I like to quickly wrap up, but I have focused on the satellite observation of the sources of greenhouse gases emissions, but I like to reiterate JAXA's effort to contribute to the global stocktake by Earth observation satellites. We are working with international partners, frameworks such as GEO Group on Earth Observation and CEOS, Committee on Earth Observation Satellites, as well as Japanese organization to utilize satellite data as scientific evidence for both emissions and removals of greenhouse gases towards the global stocktake. And in terms of emissions, we expect to contribute to global stocktake through observation data from GOSAT, as I mentioned. That was first satellite dedicated to greenhouse gas observation, and its successor GOSAT-2. And in terms of removals, we aim to contribute to the global stocktake by elucidating the carbon budget over land areas in the field of agriculture, forestry, and other land uses, AFLU and so-called, in conjunction with L-band SAR, sympathetic aperture radar SAR, and optical satellites and LiDAR technologies. Oops. Well, I'll skip here. We are operating the tropical forest monitoring with JICA, Japanese International Cooperation Agency, to detect the loss and changes of forests around 87 countries and around the world, which is used by local authorities to monitor the illegal loggings. And so this is the summary of contribution to the global stocktake submissions. We submitted 5 items to the UNFCCC. Please go to the website for the details. And in the last, I'd like to introduce the JAXA's data distribution system. The data is all free and open to everyone on globally. So please access to this website and use the data. Thank you.
Thank you very much, Harada-san, talking about the GGs as well as land ecosystems. So yeah, now we have the remote speaker, Ecosys Wando, talking about the ocean color monitoring. Please.
Okay, thank you, Hugo, for introduction. So what I'm going to introduce here is the ocean color remote sensing for harmful algae bloom research and development, which is quite different topic with the previous talk. And by definition, the harmful algae bloom is a condition when the marine or freshwater algae or phytoplankton unexpectedly overgrowth, and the bloom can cause a negative impact on the marine organism, human health, and sometimes can be cause very serious damages on the fisheries industries and cause huge economic losses. So the harmful algae bloom is a global problem, and this is seems to be caused by the eutrophication, the increasing rate of inorganic nutrient from the land to the aquatic environment, and this eutrophication itself usually can be caused by the increasing rate of fertilizer. As can be seen here, there's a tendency of increasing use of fertilizer globally from 1960s. So in the Asian water itself, there are more than 1,000 cases of harmful algae bloom every year, and half cases in the Asian water are mainly caused by the high abundance of non-toxic phytoplankton, and can also be caused by the abundance of the toxic phytoplankton. And for the toxic cases in Asian waters, there are 2 main toxic cases, which is diuretic shellfish poisoning and paralytic shellfish poisoning. Okay, so the map in the top here actually mentioning the report of the harmful algae bloom and the negative impacts such as the fish climb and the shrimp massive kill caused by the harp in the period before 1990, and in the map in the bottom also the same, but for the period after 1990. So there is a tendency of increasing harmful algae bloom cases and the negative impact caused by the harp. And recently, last year in September 2020, in the water southeast of Hokkaido, a very destructive, harmful algae bloom also occurred, and the bloom caused very serious industrial damages with the total economic loss around 67 million US dollar. So the local government and the relevant stakeholders have implemented a 5-year roadmap to restore the fisheries production to the level before the harmful algae bloom outbreak. And the roadmap contains 5 main countermeasures, grasping the actual damages, investigating or research, including the monitoring of the marine environment, restoration of fishing environment, production recovery, and some support for the business continuity. Okay, back to the remote sensing application. One of the challenges in the hub research, especially if we are talking about the remote sensing application for detecting hub species, is that the phytoplankton species or group responsible for the harmful algae bloom can be very variable. It's depend on the region. The species responsible for hub can be very different. So there are actually several algorithm or model, satellite-based model algorithm for mapping the hub causative species. And I just mentioned 3 of example here. Them is for detecting harmful algae bloom caused by Noctiluca scintillant species in the Arabian Sea, and one algorithm for the detecting Karenia mikimotoe for the Seto Inland Sea, and for Chatonella species for the Ariake Sea, Japan. So these 3 example algorithm and other similar algorithm are actually based on the apparent optical properties. So meaning that these 3 similar algorithm are merely rely on the spectral shape of a satellite remote sensing reflectance, whether they use the ratio or the difference of the remote sensing reflectance at a certain wavelength range. Okay, so there's another approach which is based on the inherent optical properties, and which has become more popular and increasingly used recently. So these inherent optical properties are using a set of the bio-optical equation or model to decompose the light into the absorption of light and the backscattering of light in the ocean. So for the purpose of the harmful algae bloom detection, this set of the this approach actually mainly to derive the phytoplankton absorption and phytoplankton backscattering. Okay, so with the collaboration with the other research group, we are doing some preliminary works to develop the equation or the model algorithm for detecting the hub species caused harmful algae bloom in the Hokkaido last year. So it's quite promising that the phytoplankton absorption at the 4443 nanometers is quite promising indicator or bio-optical properties for separating the hub species Karenia mikimotoe from non-hub species diatom. So this work still ongoing. So this is just the preliminary research. So we will still work further with for validation and verification with independent data set. Okay. So even though the South Asia frequently suffer from the red tide or harmful algae bloom, so far there is no adequate real-time monitoring system for monitoring harmful algae bloom in the ocean waters. So the only available monitoring system based on a satellite is hub, which is developed by the University of Philippines. But this system is based on the low resolution MODIS data with 4 km resolution, which is not enough for monitoring the small embankment and coastal region. So, for example, if you want to monitor the Jakarta Bay with we have frequent harmful algae bloom in this bay. So if we use the 4 km, we cannot see any detail of the harmful algae bloom. But if we use higher resolution, like 250 meters from the AGLI, then we can see some more detailed pattern of the bloom. Okay. So that's why we, under collaboration with the JAXA and the Tokyo University, we are now developing the near real-time monitoring system, ocean color monitoring system, with this target area. And there is some box here, actually the target area for to be covered by the monitoring system we are developing. And this target area actually requested by our colleague from Philippines, Indonesia, Malaysia, and Thailand, because of this region are frequently suffer from the harmful algae bloom. So this is these are some interface of the real-time monitoring system that we are developing right now. Okay, so just for a summary, yes, HAB is a global problem, and it can cause a very serious problem with to the marine organism, public health, and sometimes can cause a huge economic loss. But we still don't have any adequate real-time monitoring system, especially based on a satellite observation, with a high resolution, spatial resolution less than 250, which is much better for monitoring the coastal water or small embayment. So that's why under the collaboration with the JAXA and Tokyo University, we are developing the ocean color monitoring system with employing the Japanese GEMM AGLI with the 250 spatial resolution. But then the challenges is we have to develop the model or algorithm for a specific region, or even for a specific species, because depending on the region, species responsible for HAB, it can be very different. And we have tried to work with the inherent optical properties, which has become more popular and increasingly used right now. And then to improve the spatial and temporal coverage, I think it is in the future, it is good to combine the multiple ocean color sensor, such as the combination of the AGLI and the Sentinel. And also, I didn't mention in this slide the powerful of the hyperspectral observation. So maybe in the future, we need to use the hyperspectral observation, because if we use a hyperspectral observation, then we can see more detail on the spectral library of the hyperspecies. And also the geostationary satellite may be also good to be applied, because we will have around 6 or 7 measurement in a day. So I think that is my talk. Thank you so much for listening.
Okay, so yeah, thank you very much, Eko-san, for the nice talk. And yeah, now we quickly move on to the next talk. Eric Zussman, talking about the policy and governance. Could you start sharing your slide? Okay, now it's in. Could you turn to the slideshow mode? Yes, perfect. Please
Great.
start.
Thank you so much, Hugo, and thank you, colleagues. So I'm going to be talking a little bit following up on some of the initial remarks, I think, offered by Ben at the opening of our important workshop today. I'm going to talk a lot about how we can make sure that when we model some of the potential benefits and impacts of different air pollution and climate change measures, how we can make sure they're actually implemented effectively. And I'll focus a lot on especially how we can integrate some of the institutional, social, and quote unquote governance issues into assessment modeling. So first, I want to highlight a very important point, is that it seems to me that I've gone to a lot of workshops that have similar themes to this one. And a lot of times when we talk about air pollution and climate policy research, the policy part of this is sort of much smaller than the work that focuses on the sort of science. I want to suggest that there's, a significant body of social science research out there that I think could help inform some of the prospects of implementing some of the analyses that look at impacts and different benefits of different measures. I highlight here, for instance, Eleanor Ostrom, but I think there's many other social scientists. And I point to this as an example because I recently presented for a group of about 30 different air pollution scientists. I showed a picture of Eleanor Ostrom and I asked how many people in the room knew who she was, and nobody raised their hand. So I think this is a sort of illustration of the fact that there are significant gaps between the fields that study these different works, and there's opportunities for working together to try to better increase the prospects of implementing some of the work that is done on the sort of impact assessment and benefit assessment side of things. And this is particularly true because I think, as a political scientist, I've seen over and over again that good science doesn't necessarily equal good policy, doesn't necessarily equal good politics. But I think a lot of times we're assuming that there's a seamless translation from one to the other to the other. And I think we need to think a little bit more critically about how to make sure that translation is, I don't think seamless, it will never be there, but a little bit less friction. And so towards that end, I'd like to share with you some work we're doing in Thailand, which is really trying to, I would suggest, fill one of the critical gaps that was highlighted, for instance, in Hugo's presentation at the very beginning. And this is a gap between some of the integrated assessment modeling that frequently features in work on co-benefits or air pollution, climate change, benefits from different measures, and then some of the social science work that I'm more familiar with. This is focusing a lot on analyzing how different types of barriers might influence the feasibility of different measures and potentially slow the diffusion of some of those measures, how we can estimate those barriers, and then also think critically of what it costs to overcome them and create enabling environments that would support the quick and widespread implementation of key measures. And so to understand this a little bit more and put some more flesh on this idea, I want to highlight some work that we've done with colleagues at IASA, Stockholm Environment Institute, UNEP, and other participants from the Pollution Control Department in Thailand. And so the starting point for this work is sort of identifying, it's typically done, different types of measures that would lead to significant reductions, in this case in PM 2.5. And not so surprisingly, we see a lot of emphasis on clean cooking, so residential energy, measures in the transportation sector, including emission standards, vehicle inspection and maintenance. I should mention the emission standards there in this case, and the GAINS model also include e-vehicles, and then also agricultural residue burning or waste burning. And so this is an analysis of potential mitigation, PM 2.5 in Thailand, or excuse me, in Southeast Asia, but it also would apply more generally to Thailand. And so my colleagues and I then said, okay, these are some of the key measures. Then what are going to be some of the challenges to implementing some of the measures that would actually achieve these benefits or reduction potentials? And so what we did is we went through a series of expert surveys. We distributed about 30 surveys to policymakers and academics in mostly Thailand, also a few other Southeast Asian countries. We did a systematic literature review of the implementation prospects of some of the key measures from the sectors I highlighted. And then we used a pretty intuitive approach for combining the assessment from the expert surveys and the literature review to understand what might slow down the diffusion of different solutions. And we divided up our barriers into four different categories, institutional, social, economic, and technological. And you can see the very quick results here of this analysis. And once again, this is only for Thailand, but basically it shows that when we look at the overall impact of these barriers over a 10-year period, the barriers would slow the implementation of these different types of solutions between 6 and 7 years. This is combining all 4 different types of barriers. And that's interesting, of course, because it suggests that perhaps some of the modeling scenarios are a little bit overly ambitious in what they project could actually happen without enabling reforms. Perhaps even more important from a social scientist perspective, this research is also highlighting that for several of the solutions, the social institutional barriers are as large or greater than the technical and economic barriers. Of course, this is important because if you look at some of the integrated assessment modeling, the more advanced integrated assessment modeling, they do bring in some of the technological and economic barriers, but these social institutional barriers are frequently relegated to the sort of margins of the analysis or come in at the end with some recommendations, but they're not explicitly included in the modeling. And so one of our recommendations, of course, is to explicitly include them in the modeling. And to do that, we've made some strides. So one thing we've done is we've looked at, for instance, the time periods of the delays. This just gives you a sort of closer view of, for the cook stove example. And it's relatively intuitive to incorporate delays into some of the assessment modeling. And just showing you what this looks like in one case, once again, in Thailand. You can see that, with delays and with some of these barriers, the actual emission reductions for PM 2.5, see the with barrier scenario is about maybe 60% of the reductions that you would get, as opposed to the without barriers scenario. So, one of the main points that we're trying to emphasize here is if you don't bring in these barriers and don't consider sort of the broader enabling reforms, that you're not likely to get the types of reductions that you really want. And so that raises the last few questions and last few points that I'd like to highlight is how can we get a better assessment of what those enabling reforms might look like? And how can we also start to think about how to incorporate some of that knowledge into our assessment modeling? And so some of the work that we've done also, again, with Thai colleagues is to think about, what does it cost already for implementing some of these programs in terms of both the government expenditures on the implementation, how much does it cost to pay staff to implement some of these programs, as well as some of the awareness raising. So these are the things that would potentially help overcome some of the institutional and social barriers. And this draws a lot on research on transaction costs. And what we've begun to do is estimate, scenarios where you have the current amount that's expended on these different types of measures that I shared previously. And then we've asked some of our experts to think about how much would you have to spend to get effective implementation with good institutional arrangements, good capacities, good vertical and horizontal integration. And you can get a sense of this. This is once again for cook stoves over a 2-year period. But one of the interesting things that you get here is that the actual amount that has to be expended on the social institutional side is not as great as what is actually being spended currently. And this might suggest that, better institutional arrangements, while requiring some marginal increase in expenditures, would actually not be, sort of doubling what you would need to accelerate implementation or get wider spread implementation. And this just shows you over a 10-year period for the cook stove example. Once again, I can get into a little bit more detail about why these figures go up and down, but this is sort of our initial attempt to understand what it costs to overcome some of these barriers. And once again, that's the type of information that can be put into integrated assessment modeling to help us move forward and help achieve some of the estimates that come from sort of the co-benefits assessments. That's all I have for today. Thank you so much.
Thank you very much. Then we move on to the question and discussion session, and we'll invite again the Harada Mariko-san here, and we are two local participants, but please, the Eric-san and the Eko-san, please join from Japan. Yes. So let's take questions, comments, if you have any questions.
Yeah, hi. Yeah, I have actually 3 questions. one to you and one to you, and then third one to Eco. So the first question is that you showed this interesting declining curves for China, Japan, and South Korea. I was just curious, like, what sectoral emission controls are more efficient in that context? So it will be very interesting for India. Okay, maybe let me ask my questions. So my question to you is that for the Go Blue program, it was very interesting. So what is the measurement strategy? Can you elaborate more? Like, are you sort of choosing a specific routes to measure, or want to cover the larger area for all the commercial airlines? And my question for HAB is that you're talking about real-time monitoring. So how are you controlling for the cloud cover in deriving the algorithm? Thank you.
Yeah, thank you very much, Sagnik-san, for the interesting three questions. And yeah, one by one we'll answer. And for the first part, your question is about the PM 2.5 long-term trend, Japan, China, Korea, as I guess. And yeah, for that particular study, we didn't do the sector-specific attribution of the PM 2.5 actually, but in a separate modeling studies for the black carbon, it is evident that, yeah, for example, the China, the domestic or the residential sector of the emission is quite important for the, yeah, for that the black carbon, but also the organics and as well as some other sulfate or something like that. So then, yeah, we should have been able to recommend a reduction in that sector particularly, but that is quite similar condition for the black carbon, further reduction into the future. And yeah, okay, yeah, that's my answer for the Chinese transport to Japan. But for the Japan domestic is also the important to control, and discussion, including the natural scientists as well as politicians and government people, such as reach the conclusion that yeah, the gas at the gas station, particularly, that some leak of the non-methane hydrocarbon, the fuel, is the one of the particular important sources, and yeah, that treatment or the control is a bit poor in Japan in comparison to other countries. So then, yeah, we have specific target about this under the discussion among these people. So yeah, the second question is about the Go Blue. So could you, Harada-san, can you answer?
Thank you for your question to Go Blue. Yeah, answering that question, we can apply any aircraft to monitor to carry the Go Blue instruments to any commercial air flight, but depending on the kind of passenger, like Boeing 787 has a digital screen on the window, so it prevents to go through the sensor. So we are now operating 777, 777 or 747 or something like that. So we need to carefully choose which aircraft we carry on that instruments. That's the thing. But we just initiated that Go Blue project last year to focus on a city to accelerate the reduction from cities. So as soon as we would like to more sophisticated instruments, we are aiming to share those instruments to other countries and all the companies who are interested.
Okay, and then the third question is about ocean color monitoring and the cloud disturbance.
Yeah.
Eko-san, can you answer to this question?
Okay, thank you so much for the question. Yeah, the cloud coverage is always the problem. Okay, with the satellite observation, especially if we are using the optical sensor, because optical sensor cannot penetrate the cloud. So yeah, that's always the problem. But there are several things that we can work with these issues. First is, as I mentioned in the summary, we may combine the multiple sensor. Okay, for example, with the same similar spatial resolution, like for example, Sentinel-3 and Japanese SGLI, that will improve the spatial coverage. That is one idea. And the second is by applying the local atmospheric correction. Okay, so with the atmospheric model, which is suited for the local condition, that will sometimes will improve the spatial coverage due to the cloud coverage. So that is two things that we can do. But even for the combining the multiple sensors is not easy, because different sensor will have a different spectral band. So we have to make sure that both band can be compatible, so that we can merge a product from a different sensor. That is what I can answer.
That's fine. Yeah, thank you. And Oda-san first.
So I have a question to Eric-san. Thank you for your talk. I was looking at the integrated assessment model result, and I was wondering, because I'm coming from science background, and how robust is your inter-annual variability you showed? Because I didn't see any error in it. So just that I don't really know how it's going to work out. So just wanted to, it would be great to speak about the robustness of the estimate. Thank you.
Some please.
Yeah, thanks very much. So we've done some sensitivity analysis of the impacts of the different barriers by changing the weighting of the literature review and the survey assessment. I can show the error bars, but they're very, very, very small. They don't change very much. Having said that, and I think this is a point that you're raising too, is, I mean, we're measuring barriers at a certain point in time, right? So to reflect how those barriers might change over time and make them more dynamic is a subsequent challenge. Moreover, and that this is also another point that we'd like to look at a little bit more closely in the future, is also the interactions between the barriers. So right now we're making an assumption, which I know is not realistic, but we're making the assumption that the barriers are basically additive, right? That the impacts between the technological and institutional barriers are, basically just stacking on top of each other. But we know in practice that there's interactions between those barriers. My sense is actually if we brought in some of those interactions, at least initially, you would have more longer and more significant delays as opposed to shorter ones. But that's something to be looked at in the future. And this is the type of thing that is featured a lot in the transition studies, sustainability transition studies. But that work, it doesn't have sort of the quantitative edge, of course, of the integrated assessment modeling. So thank you very much for the question, though, and this is really good points to think about it as we publish this work. Thank you so much.
Okay, thank you very much. And last question is from Dr. Bharti, please.
Yeah, the question is to Eric. So the cooking stove model, the study which was conducted for Thailand, perhaps the clean cooking mechanisms, that's a question, and it remains true for so many other countries, as in India too, right? So, so when you're looking at various barriers, in terms of translating it into effective, say, solutions, what would be your suggestions to it, like fuel stacking or something like that, or anything more effective?
Yeah, thank you very much for this. So I think we're trying to do this on two levels, right? So one is before I get there, first I want to really underline that this cooking issue is a huge issue, not only in Thailand. I mean, it's mostly northern Thailand that has the challenges, but throughout much of Asia. And if we can solve the cooking problem, I think especially in terms of the health benefits of air pollution will go a really long way. But it's been a challenge for 30, 40 years. It's not something that started new. Having said that, in terms of working towards a solution, I think what we've noticed is, and this in some ways goes back to the work of Ostrom, right? That you need to think about the technology. Okay, so there's different types of technologies or different types of social changes that happen in the community level that work in different contexts, right? And so it's very context specific. And in some cases, it's improved cook stoves. In some cases, it's fan-assisted cook stoves. In some cases, you're switching to different types of fuels. So that's very, very context specific. But having said that, the more general approach to how to resolve these issues in some ways involves going sort of one level up, right? To think about the sort of broader environment in which the types of technologies are selected. That type of environment generally needs to be, focused on being very inclusive, bringing in cook stove users. So I've had some experience, for instance, working on these issues in Cambodia. And in that context, we made sure, of course, to engage with women's groups. We made sure that many of those women groups were involved in the manufacture of the technologies or the manufacture of the clean cook stoves and the marketing of the clean cook stoves. So that created strong incentives for them to get behind and push these initiatives forward. So you need the technologies, you need the sort of broader enabling environments that are context appropriate, where people can select the technologies that are good for them and then motivate them to get involved in that process. And then at even a higher level, at sort of the moving past the sort of selection environment, you need government policies and programs that help spread some of those inclusive participatory channels. And so there's, sort of multiple levels of interventions that are typically required to help close some of these barriers. And I think one of the things that we'll be able to do with this sort of modeling is to show if we don't have that type of multi-level enabling environment in place, it's very difficult to close these gaps. And then by creating that multi-level enabling environment, also what it costs to do that, that's when we start talking about the public policy programs and the social awareness raising. So once again, it varies a lot from one context to another, but I think those are some general ideas that can produce this type of transition in a way that can help close some of these implementation gaps. Thank you. Does that make sense? It's very social science, but I hope that makes sense.
Yeah. So thank you very much. And there can be some more questions. And we have also our own question, how to integrate all the information here. And also, there seems to be a chat, in the question in the chat box. But we try to be able to, respond to that in the meantime, in the lunchtime maybe. So then, having said that, then maybe, our talk today is a bit individual, but we hope to integrate this context into all the sessions in the coming, for today and tomorrow. So having said that, I'd like to thank all the speakers here and all the participants. So thank you very much.